All right, let's take a look at today's lesson. We're going to be working some more with statistics. We're going to work on analyzing some data. So first, let's look at the measures of central tendency. I'm sure you are familiar with these. You would have encountered these in a previous math class. Measures of central tendency. So mean, that's the average of all the numbers. I know you're quite familiar with that. Median is the middle number. Okay, do you remember what to do if there's an even number of numbers? Let's say there's 10 numbers. Even number of numbers. What do you do? Remember? Right, you take the two middle ones and average them. Take the two middle numbers and average them. Just a little reminder. Okay. Then our other measure of central tendency is mode. This is the number that occurs the most frequently. And then we have a fancy name. If there are two numbers that occur most frequently, it's called bimodal. Okay, bimodal. All right. So let's look at some other measures. These are measures of dispersion. So that just sounds like the English word dispersion, dispersed. How is the data spread out? The variance measures how far the data set is spread from the average value. This X with a little bar on top is a shorthand notation of mean. So you can write X with the bar on top to replace the word mean. With just a little shorthand that we could use. So looking at the formula for variance, notice that let's say we had 10 terms, okay? So we take our first term, we subtract the mean, and then we square it. We take our second term, we subtract the mean, and then we square it. And we keep doing that for every single term. Then we divide by the number of terms we have. So as you can imagine, if we have a lot of pieces of data, that would be really time consuming. So somebody has programmed into our calculators this formula, and our calculators do it for us actually very quickly. So that just is the actual formula for finding variance. We will let our calculators do that. Then standard deviation is the measure of how one of the numbers in the set differs from the mean. It's also just again, we're measuring how spread out they are. And this little symbol right here is the lowercase sigma. This is what we typically use to say mean. That would be the mean. And the mean is the square root of the variance. All right. So let's look just briefly. Our calculator does two different kinds of standard deviations. So you'll see like this, standard deviation X. That means that is the population standard deviation. I'm going to just abbreviate standard deviation. That's for population. Then you will see one that has an S, and S is for sample. This is for the sample, a sample population, a sample standard deviation. Remember we talked about that concept in a previous lesson where the population, that means everything. Like if we're going to look at, say, studying eagles, it would mean all of them. And so to do a population study would be very difficult, actually. We normally would do a sample of whatever it is we're studying. So it's important if they ask in a question for the population standard deviation, we would look at this number. The numbers are close, that they're slightly different. And but I kind of default to sample. Most of the data that we work with is just a sample of all of the data. So just kind of throwing that out there so we understand the difference between those two notations in our calculator. Okay, so let's, I want to go to one other overview page before we start on our problems. This overview is on quartiles and box and whisker plots and normal distribution. So you've probably already seen these before. We're not going to do practice on these, except that in the application we're going to do in this unit, you are going to have to draw a box and whiskers plot, which you've probably already done before. I'm just going to remind you how that works. So the Q2, the Q2, the quartile 2, the middle quartile, that's actually the median. I mean, we know how to find the median, right? It's a number. So that's the median. Q1, what we do is we take the data and we split it into two pieces. This is an odd number. So we would take these three terms, and these three are the numbers, and we would do the middle one. The middle, it's like the median of the lower half of the data and the median of the upper half. So the median of the lower half is Q1 and the median of the upper half is Q3. And that's what is indicated in our box and whiskers plot are those three numbers. The box starts at Q1, it has a line at Q2, and it ends at Q3. Okay, so just a little review or overview of how that works. Normal distribution is the bell-shaped curve. You may see problems about it, maybe on the SAT or ACT. What that's talking about is, if you look, this is the middle term, the mean. Then we would add, this is a standard deviation, one standard deviation plus and one standard deviation minus gives us this middle part in the blue. So 60, if we have a normal distribution or a bell curve, 68% of the data would fall within one standard deviation. So I'm just explaining that so that we have a frame of reference for a problem that we're going to be doing. Just for instance, let's just pretend that 20 is my mean. Okay, let's say that my mean is 20. And let's say that my standard deviation is 5. So if we want to be within one standard deviation of the mean, we would add 5 to 20 and we get 25, and we would subtract 5 from 20 and get 15. So the numbers that fall between 15 and 25 would be the numbers that are one standard deviation away from the mean. Okay, I just wanted to give you that little example with some simple numbers so that when we encounter it in some problems in just a few minutes, that will make more sense. Okay, so now let's look at some problems. So we just have a couple problems we're doing. The first has to do with looking at some data and deciding which one of the measures of central tendency would be the best representation of the data. So let's look at the first one. As we look at this one, we see that a lot of the data, so this is a frequency, I'm just going to remind you what the frequency is. So 1 means, like, say for example, these are marbles. Let's say I have 1 marble, 2 marbles, 3 marbles, so on. So what this means is 7 people have 1 marble, 20 people have 2 marbles, 15 people have 3 marbles, and so forth. All right, so we see that the frequency or the numbers kind of group in here. They're grouping in here and more heavily right here, okay? So if we're going to figure out which of these numbers would be the better representation of the data, we really wouldn't pick the mean, which would fall in here. That's not really where most of the data is. So instead, we would choose either the median or the mode. I would, and again, this is where statistics gets a little bit fuzzy, I guess. If we have an argument for our, choice, and we can back our argument up, then we'll go with it. I'm actually going to go with 3. I think that's the better representation of the data because the median, because so much of the data is grouped down here. It's grouped down here, so right through here. So I'm going to say it's the median because most data is grouped around 3. Okay. So the next one, if you notice these numbers, they're very spread out. There isn't a grouping like in part A. So for this, I would go with the mean or the median. They're the same number. And this is because the data is more evenly distributed. Okay. And then the last one, we've got mean, median, or mode. Let's see. These are also fairly evenly distributed, so I would pick one of these two numbers. And again, I would say because these are more evenly distributed, the mean or the median would work. Okay. Let's look at our next one. Now we're going to need a calculator for this. Hopefully you have your calculator handy. This table shows students' 6-week averages. They want us to, number one, we want to find the mean. Number two, we want to find the standard deviation. And then they ask us a question we're going to have to figure out after we do all the data, find the data. It's what percent of the data values lie within one standard deviation of the mean? Okay, so we're going to have to kind of work that out after we get our numbers. So let's focus on getting our numbers. Let's see, what do we have? We have student names and we have their 6 weeks average. So, okay, so let's switch to our calculator. I'm going to pull up our calculator. I want to talk about, there's several steps to be able to do this. So first off, we need to insert the data into a spreadsheet or list. So you would open up a new document. You wouldn't use your scratch pad. You want to open up an actual document and you want to add list as spreadsheet. Once you get this open, you need to come up here. So I'm going to hit tab and you need to fill in. You need to enter a word here. It really needs to be at least 3 digits long because the calculator has a lot of 2-digit symbols. So we get at least three letters. I'm going to call it score because that's what we're looking at. We're looking at their score. So I'm going to call it score, and then I'm just going to hit enter, and then we're going to come down here. This is where we're going to enter those numbers that were on the table. So the first number was 59. I'm just going to go through and enter all of those numbers. If you have the notes in front of you, you can follow as I'm entering these numbers. I'm just copying them straight from the table. Okay. We have 25. I'm not sure what's up with that 6 weeks average. That's a little painful, but okay. 56, 66, 75, 32, 42, 37, and 97. Something really important is we're supposed to have, there are 14 students, so we do have 14 numbers. It's really important to double check the numbers that you enter. Even if you get 1 digit wrong, it's going to make your answer wrong, and that would just be really sad to do all this work and with the answer being wrong. So let's double check. If I enter it like this, I usually double check going up. So 97, 37, 42, 32. Let's see, 75, 66. 56, 25, 54, 36, 70, 87, right? Okay, all looks good. Great. So this is where we put our data. All right. So to get numbers, we're going to need to, to find the average and all that kind of stuff, the mean. What I want to do is I want to open another document and see the little blue plus page. So I'm going to do Control Doc, and that's going to give me a new page. And in my new page, I want to add a calculator. So I want my calculator here. So once I have my calculator here, in order for my calculator to do all the work for me, right, to do all those number crunching, so I'm going to go to Menu, and under Menu, see we've got Statistics here. we want to do stat calculations, and we're working with one variable statistics. We just had one variable, you know, one column. Okay, we just had one column or list. And up here, you have to hit this little arrow, and if you had several lists, you would just be able to pick from them. I only have one, it's called score, so I'm just going to highlight that. There's just one of them, so I'm going to hit OK. So this is all the data that it gives us. It gives us a lot of data. This X bar, this is the mean. We're going to copy that down, it's 56. We're looking through here. This is the sample population standard deviation, and this is the population standard deviation. Depending on which one, if they ask for population, you would give them this one, 20.4765. If it's just a sample of a bigger population, which is the vast majority of what we're going to be doing, you would use this number, the 21.2494, and that's the number we're going to use. So in, that just tells me how many numbers that I had. There were 14 numbers, and just some other additional information down here that we won't be using. So it gives us a lot, but we're just going to be using the mean and the sample standard deviation. So let's go back to our document and let's write those down. So we've got our mean was 56. Our standard deviation, I'm just going to use this shorthand notation. I'm just going to do that lowercase sigma is 21. We're going to do the sample population, 2494. Okay, so what they're asking is we want to know what percent of the data values lie within one standard deviation of the mean. If my mean is 56 and my standard deviation is like 21.2494, what would I do? Yep, you're right. I would take the 56 and I would add 21.2494. Since all these numbers are integers, I'm not going to worry too much about all those decimal places, basically like 77.25. Then I would take my mean and subtract one standard deviation. And that would give me, let's see, 34.75. Okay, so my interval is between 34.75 to 77.25. Okay, so that any number that falls in this interval would be within one standard deviation of the mean. Okay, remember the little example we did earlier with the 20? You know, I had a 20 here, and then the standard deviation was 5, so we would go between 15 and 25. This is what we were talking about. That's what we're doing. We're within one standard deviation. So now our job is to look at every single number and determine if it lies inside this interval or not. So 59 is certainly between 34 and 77. Okay, so that one counts. 48 lies in there. 87 does not. 87 is outside the interval, so I'm not going to count that one. 70 is, let's see, 36 works. 54 works. Does 25 work? Nope, that's outside the interval. It's not going to include that one. 56 works. That one's good. 66, let's see, 75. Yep, that's still inside there. 32, no, 32 is not inside the interval. Let's look at the next one. 42, that works. 37 works. And 97 is not in the interval. So we're going to count up how many are in the interval. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 of these marks, as they're called, out of 14 are the data values that lie within one standard deviation of the mean. Now they wanted the percent, and I'm sure you remember how to do percents, right? We multiply by 100, so this is going to be 71.43% of the data lie within one standard deviation. I'm just going to abbreviate that, standard deviation of the mean. Okay, so here's our first two answers, and there's our last one. All right.